Hello, and welcome to Calculus One. So this summer we'll be learning Calculus One online, which is a different experience for many people. So the way this will work is that you'll be watching my recordings, and then the assignments will all be available on Brightspace, which I'll discuss with you in a minute. So first, let's take a look at the syllabus real fast. By the way, at the moment, all of the materials for this class have been posted on Brightspace. So actually, I'll tell you what, let's go look at Brightspace first so that you know where to find it. So if you go to SUNY Purchase's website, of course, I'm looking at the faculty and staff page, but Brightspace is here, and you'll click it on, and you'll find your course here with all the materials you need. So a couple things I want to point out. First, there's a few different ways of looking at it. These are all the different categories that I've set up. And you can look at it in a couple of different ways. If you go to content, you can ask it to show you everything all at once, or you can do it one at a time. Table of contents will show you the entire list. And then here you can see there are many different modules, as they're called. And so at the very top, we have this very important link that I'll discuss with you in a minute. But first, I just want to point out that we have this introductory document called Prepping for Purchase. So the school has put this document together for you so you have everything you need to know about the class and what you're expected to do. And in fact, why don't we quickly open it up for a second and take a look? All right, hold on a second. All right, so I guess they're giving you the basic requirements for the course. You, of course, should have access to a computer to do an online course. They expect you, of course, to do your own work, of course, to pay for the course. They want you to know how much time you have to withdraw from the class if there's some reason why it becomes necessary. Just be aware that this is, the school calls this session 2. Okay, if you look at the academic calendar, on their website. It's listed here somewhere. Here we go. This way you have you can see what the dates are for this course. So if you scroll down to summer session 2, you'll notice it starts on Monday the 2nd of June and it ends on Monday the 28th. So it's an 8-week course, which is roughly half of the normal time. And so that means that, of course, we'll be doing everything at a somewhat accelerated pace compared to the school year. But that's what you normally expect to see during the summer session. A lot of summer classes are a lot shorter than this. I've had classes that were, God, 3 or 4 weeks, and those are really accelerated. I think something like this, calculus, probably half, or half the normal time is probably the best. This way, you do have quite a bit of time to study the material and get your assignments done. And yet you still have time to do other things too, like you have time to work and you can go on vacations if you need to. The beauty of a setup like this is that you're completely on your own as far as the scheduling goes. You can watch the recordings when you want to. And as we'll discuss in a bit, we have assignments, but they're all going to be done online. So you have absolute complete flexibility. And now, having said that, though, if there are genuine issues, you can get in touch with me, and my information is on the syllabus, and let me know that you might need, for example, an extension of your work, or there might be a problem you need me to know about. But basically, this is a very self-guided class. Okay, so you've got 8 weeks, and there's other important dates in here too. For example, if you realize that you can't really do this class, you can still withdraw. I guess they'll give you your money back. I don't know anything about that side of it. And you could, in principle, ask to take this class on a pass, no pass basis, but I don't know if that means that you'll get credit for it at your school. So you have to ask about that at the registrar's office. The last official withdrawal date is July 7th, which means halfway into the course. If you're thinking that maybe you shouldn't do this, you can still withdraw. But then if you wait that long, I doubt very much you'll get your money back. And then the very last day is the 28th. So all that information is here. So anyway, let's get back to the prepping for purchase document. So this is a lot of more information that you might need for various reasons. Oh, here it is. I guess the policy for refunds is listed separately. Um, this COVID thing, you can imagine that was put in there a few years ago during the height of the COVID. I guess now nobody's required to worry about that anymore. So yeah, so all the things you might need are here. You don't have to worry about parking, obviously. You don't need an ID. Now, of course, many of you are purchase students. You already have all this, so you don't have to worry about it. But if you're not a purchase student, even then, you're like normally you would have to drive to the campus and get a parking sticker and all this and that, but you don't have to worry about that since it's an online class. So, there's information here that you might need. But anyway, so it's here if you want this document, but the information for contacting me is on the syllabus. Okay, so let's go look at the syllabus for a minute. All right, so this, by the way, this is actually posted on Brightspace. If you come back to the table of contents, here we go. Here's prepping for purchase. Here's your syllabus. I'll show it to you in a second. And then these are the notes. Now, these are the notes that were written by the author of the textbook. So we'll be leaning on these very heavily, but I will also be adding my own content as we go along too, especially in the sense of doing practice problems. I think that, calculus is the kind of material that we learn it best by just doing it. Okay. So anytime there's a need for more practicing, I will provide more problems and we can work at them together. Okay, but this is the basic content of the book. And so the course is based on these. And you can see there's a preliminary section, which is meant to help us review what we learned in previous math classes, such as pre-calc. And because, it's possible that it's been a while since you saw this material and you might need a little refresher or some of this material might be new to you. We're going to start there, but there won't be any assignments based on this section. That will start with chapter 1. And you can see there's 5 chapters, but each one has a lot of sections. Okay, there's a lot of content in this course. And and by the way, here's an example of what I was referring to earlier. This is something I wrote. These are extra practice problems that I wrote. We're going to go over them when we get to that chapter. So everything's here, even as soon as you get access to Brightspace, you can start reading these slides if you want to. And when we're done with the recordings, I'll be posting them here on Brightspace, so I have no trouble finding them. I also will put them on my YouTube page just because, this is what I had done in the past. Brightspace has the ability to store videos, but videos take up a lot of space. So there have been situations where I used to have to record everything and put it on my YouTube page because like even here at Purchase, we used to use this system called Moodle, and it simply did not have the capability of storing a lot of videos. So I'll put it in both places just in case. And so if you go to YouTube, here I am. See the little red A. So you're looking for this, I guess, is how you uniquely identify me on YouTube. If you type that in, you'll find my page. And then what I've done is I created a series of playlists. Here we go. And so you'll find it. There'll be one for this course, and it'll all be there if you want to come here to look for your videos. And while you're here, you'll notice there's a lot of course materials here. You can feel free to look at any of them. They're all courses that I've taught in the past. They're all open to the public. Yes, you may look at these if you want. The videos and stuff that I save for myself, they're over here somewhere. I don't think you can see those, but why would you want to anyway? So, all right, anyway, so all the slides, all the slides are here. The lectures will be recorded and I'll post them in the appropriate categories when we're done. So you can come back and watch them. Now, you can watch them as many times as you want. You can run through them and see what we're doing. But if you still have questions, if you still want to chat about questions or problems or just review or whatever it happens to be, even though this is a completely online course, I still can have office hours. So the way that would have to work is I'm using the Zoom system to record these videos. And so what you can do is send me an email. The email is listed right here and say, I'd like to get together and go over this topic or that topic. And then we can arrange a Zoom session and do that separately. Okay, so there's always help available to you. Or if you have simple questions that don't require a Zoom session, you can just send me an email and I'll let you know what's happening. That's especially important if you run into technical problems. With the thing about an online system like this is there could be times when things aren't working correctly for God only knows what reason. I'm not a technology person, but Cengage, who is the learning system that we're using, is very good about technical support. Okay, a lot of companies are not good with technical support, but they are. So if you find that your system isn't working, something's not going right, or if you think that some of the questions have the wrong answers or anything like that, you can just let me know, and I'll go over it with you. So, I'm always here if you need me. Let's put it that way. Okay. All right. So now we need to go over. See what else do we need to look at here. So the syllabus also has other information: the name of the book, Cengage system, an overview, a discussion of the topics we'll be covering. The Zoom system is being used. So you'll know what to expect. You know what's coming. Now, if you're attending a different school, you probably had to show this to your home school to get it approved anyway. If you're attending Purchase, this is exactly what you would have gotten if you'd taken a normal in-class, in-person class during the school year anyway. So these are all the content that we'll be doing. Now, because this is online, you're going to get a lot of online assignments worth 40%, and there's going to be 2 exams also that will be done online using this WebAssign system. So why don't we take a look at WebAssign right now? First things first, how do you sign up for it? If you go to the Brightspace page, there's a little link here. Now you see how it says Access WebAssign here. This link, I'm not going to turn on now because I'm not sure how to react because I already have it. But if you click that on, it should, in principle, give you the details and instructions for how to sign up for your WebAssign account. Now, unfortunately, there's a fee involved, okay? And it's like $100 or something, but it can't be helped because this is the only way we can have an online class. And so when you click it on and you set it up for yourself, and I see some people have already taken care of it, when I had this thing set up, they explained to me that they didn't want it to be available until, I guess, May 31st for some reason. So if you tried to set it up earlier this week, you probably ran into problems. Now it should be open and ready to go. Okay, it should be possible to set it up and get into this WebAssign, which I have right here somewhere. What happened to it? Oh, here it is. So this is what it would look like. You would go, this would be your page, and you go to your Calc 1 course. And what you're going to see here is that, first of all, good news, you get access to the textbook on this website. Okay. So if you go back, let's see. Oh, here it is. Sorry. Ebook. Yes. So in other words, if you want to read the book, in addition to looking at the slides, here it is. Buy a separate copy unless you really want to. And you know how expensive these books are. This one is rather hefty. It's probably at least $200 in the bookstore. So you can read through all the chapters here. Now, by the way, when you're doing the assignments, among the many nice features is that if you get stuck on something, it'll give you a link so you can go into the book and read more about whatever it is you're working on. They also offer a bunch of videos you can watch to help you with these problems. So the WebAssign system is actually designed to be as helpful as possible. I mean, it's really set up to be very user friendly so that if you get stuck, something is wrong, you don't know what you're supposed to be doing. Oops. Okay, I think I mentioned this before. I'm not a technology person. Oh, but the most important thing you'll find here, besides the goals, is the assignments. Okay, so let's get that. Let's take a look. So besides the textbook, um, you'll see a bunch of assignments listed here with the due dates. Now I have a bunch of other courses here. You should only end up seeing just this one, the Calc one. And now, because the course technically hasn't started yet, they're all listed under the category future. I usually just click on all just to see them all at once. So here they are. Now it looks like you're saying, oh my God, all those assignments we have to do. Well, remember, this is a full semester course, and this is going to take place over 8 weeks. So the due dates are over here. Looks like, oh, that's right. I almost forgot. I did create a brief assignment for the preliminary material on my own. Okay. I did forget about that. So it's just, um, oh, no, this is the editing. Well, anyway, it's there. If you want to look at it, here we go. Now you can see, oh no, you shouldn't see that. You'll be seeing the answers. But when you click it on, the answers won't be there. Okay, let's put it that way. And so you're going to put your answers into the little boxes. It's going to help you by telling you, for example, if it needs to be rounded, but to a certain number of places. Read the instructions very carefully. They're going to try to give you helpful hints as to how to properly enter the information. A lot of issues can come up when people aren't sure how to actually enter the numbers. That kind of thing I can help you with. If you're stuck, you're like, listen, I keep typing this number and I'm not getting it. There's a setup here somewhere where you can send questions directly to me. You see this little 11 here. These are questions from past classes. So I see this little bell here and it says, oh, you've got 11 questions. And so I can go in and I can see what your questions are. But I'm not absolutely clear how you send those to me. I'm not even sure I have access to that. Communication, maybe. Oh, yeah, I'm not absolutely sure how that works. Because I don't obviously send messages to myself. But also, what's good about this is that if you need, let's say there's some reason like you went on vacation and you just don't have time to finish the next assignment, you can request a time extension through this system, like, this kind of thing. This is from another semester, so it won't be the right dates or anything, but oh, here it is. Wait a minute. Oh, look, I didn't even see that. It says ask your teacher and extensions. See, but I'm not sure how you send that to me. I'll have to ask about that. I know that the interface you have is different than mine. But somewhere in here, there's a way you can send me messages directly. And if not, you can just use emails. I'll be looking for both. I've never asked anybody how this works. Um, yeah. So it's in here, but this little box tells me that somebody's sending me a message, and one of two things is happening. You're not sure about a question. Um, why is this the wrong answer? That kind of thing. And or possibly I just got back from a long vacation. Can I have another few days for this assignment? That's where this type of information belongs. Okay. So yeah, no, it'll if you haven't used this WebAssign system before, it will take a little getting used to. And that's to be expected. So if you run into issues, just let me know and I'll see what I can do about fixing them. Now, if it gives you the wrong points or does something incorrectly, I can fix that. Or if there's something that's not clear in there, or if it's something that maybe somehow didn't cover, I can make the necessary adjustments. So just let me know if there's an issue. Now, the one thing that's not in here, I haven't posted the exams just yet. That's going to take a while, but the week-to-week assignments are all in here right now. So they're all open as we speak. So while there's all these due dates, you don't have to wait to try them. In other words, if you think you can do all of these today, you can feel free to go right ahead. There's no penalty for getting them done early. Also, one more thing, I set it up this way on purpose. When you try one of these problems, it'll give you up to 3 opportunities to try it again, and it'll take the best score. Okay, so in other words, if you try it and you said, "Oh God, I did so badly," you'll have the opportunity to try it again. You'll have a total of 3 tries, and it'll always take your best results. Okay, so sometimes you're not sure what to do, and you try this, you try that. This way, you don't have to feel like, oh my God, I'm going to ruin my grade if I get something wrong here. No, you'll have plenty of opportunities to try it again. Okay, so that should make things a little less stressful, I think. So anyway, I think we kind of got all that out of the way. So since we have a little time left here, why don't we go ahead and start the new material? Now, remember, we're going to start with the preliminary um, review. If you look in your right space, you'll see it right here. You can tell because of this P1. This is their numbering scheme. It's got the title of the book, and then P1, 2, 3, and 4. These are the slides we'll be using to review. It's preliminary or preview of calculus, and then we'll start the brand new material here. This is where calculus starts. Here, we're kind of overlapping with pre-calculus, just to refresh your memories about these important concepts. Okay, so you can download these slides anytime you want, by the way. And you know, because you since you are in the course, you own the book and you own the rights to use these slides. Okay. So, all right. Anyway, so the first one. Now, by the way, some of this stuff is going to seem really elementary, but we do have to review all of this stuff. So, we'll get started right now. And let's see, let me make sure it's the right one. Yeah, this is it. So they're going to actually have us start by reviewing very briefly graphs. Okay. So now, of course, graphs are very important in all branches of math, but it's very important in calculus because we need to be able to visualize what we're doing. And by the way, I'm going to show you something very interesting that you can do on the internet. Suppose you're working on a problem, like I really can't visualize what this function looks like. Let me just make a note to myself. Now, there's a couple of these, but the one I like the best is this thing called Simple. Now, they just added this title recently, AI Math Calculator. I don't know if it's really AI or not. I don't know enough about AI, but let's say that for some reason you need to know what the graph of y equals x squared plus 3 looks like. You're like, geez, I'm not sure. How does that look again? You can say, well, please give me the graph. And voila, there you go. So in other words, it's important to understand graphs in calculus, but it's nice to know that there's help available if you need it. And this is free, by the way. I mean, I have the paid version, but it's completely free. And it works pretty well. I mean, it's not perfect. It it can run into issues, but now having said all that, if you're going to be actually majoring in math, there is a professional package out there called Mathematica, which is basically Symbol Lab raised to like the 10th power. And the reason why I'm bringing this up now is because if we're really going to go in this direction, it might be helpful to learn how to use the system. It's very powerful, but it's also hard to learn it, or at least harder than Symbol Lab. If you're a SUNY Purchase student, you may not realize it, but you have access to this software. You can request a free license and download it onto your own computer and learn how to use it. At other schools, I'm going to guess that the same thing is true. I'm guessing that Wolfram has made a deal with probably every college in the United States in order to provide this for free to students so they can learn it and then use it when they graduate. So you can see it's very, very powerful. This is what professional mathematicians use. And so just be aware that it's available if you want to use it. Okay. If you're willing to put in the time to learn it. If not, if you don't really need it that often, you're probably better off with Symbol Lab because it's really easy to use. All right. Anyway, let's get back to this. So graphing. So along the way, they're going to teach us a lot of techniques for recognizing how a graph looks. It should, in principle, be possible for you to at least draw a proper sketch of a graph just by looking at its properties. Here's a perfect example of that. It should be pretty clear that this is simply a linear function. It's a straight line. That's all there is to it. So now it's not arranged in the standard way. Hold on a second. So, by the way, I have this wonderful tablet here that lets me write directly on the screen. What is it again? 7. Now, of course, you know the standard form for a straight line. I'm going to rewrite it. And then it's clear that this is M, slope. Or sometimes in high school, it's called the rise over the run. And this is the intercept, specifically the vertical intercept. So you should be able to guess or take a good look or write a very good sketch of this thing. So this is the point 0.7. And 3 is a pretty steep slope, so we'll just write it like this. Oh, wait a minute. I'm sorry. I didn't even see the negative there. Sorry. Hold on. All right. We got to go the other direction. Okay. So we have everything. Now, if you want to be even more exact, you could actually figure out the x-intercept, but we don't really need to do that right here. So in other words, as long as we know the slope and the intercept, that's really all we need to know to uniquely identify a linear function. Okay, of course, it's a straight line, and it can have a positive slope, negative slope. Now, there's 2 other special cases we need to know about. Here, the slope is undefined. If it's a vertical line, and then if it's a horizontal line, slope is 0. Okay. So those are the only 4 cases we might encounter. Okay. So this is a linear function because it can be described by a straight line. All right. Now what they're doing is making a point here that you can, if you need to, find different points in this line just simply by substituting them in. For example, let's just use 1,4 as our example. How do we know that it contains the point 1, 4? Well, let's plug in some numbers. So 4 equals 4, of course, that's a true statement. Therefore, 1,4 must be part of this equation. All right, and 0.7 as well. And that, of course, is nothing but the intercept. If you're still not sure, I mean, you could draw a bunch of points or choose points and then sketch them out, but you'd eventually see that it looks like what we just described. Now, this one is a little different. This one has an x squared term in it. So when it has an x squared term in it, it is said to be a quadratic function. And you'll probably remember from your travels in mathematics that this means that it can be described by what's called a parabola. Okay. And in general, a quadratic equation is written as y equals ax squared plus bx plus c. Okay, so here a is 1 and c is -2. So a couple of things we can tell already just by looking at it. With parabolas, there's really only two cases we might encounter. Either it's facing up, and it has this very unique shape. It's like a big U, basically. And so if A is positive, it'll face up. A is negative, it'll face down. If A is actually 0, then it reduces to a linear equation. So then we don't need to worry about it. So the other thing that we need to notice is that the C is the vertical intercept, okay, because that's where x equals 0. So that means that whatever we have here, and again, this is just meant to be a sketch. We know that it's facing up and that the intercept is -2. And that's it. If you're not sure, if you just want to check with Symbolab, you may certainly do so. In fact, it's very much like the one I picked as an example before. Yeah, there it is. That's exactly what it is. Now, if you want to, later on, we'll see how you can find where the parabola crosses the horizontal axis. These are the two solutions of this quadratic equation. You could, for example, use the quadratic formula, if you remember that from high school math or pre-calculus. So there's two solutions because it's a quadratic equation. We'll call them x1 and x2. And so those are the coefficients, as we've already seen. Is 0 because there's no x term here. So we're going to have okay, so the 0 drops out, 0 plus 8. Now, of course, radical 8 can be simplified in the following way. Oops. Remember with radicals, they're called, you can break it down into a product of other terms. Like here, I can rewrite this as radical 8 equals radical 4 times radical 2. Why am I doing that? Because look what I can do now. This suddenly becomes 2. So this ratio is 2 radical 2 over 2, which means it's nothing but plus or minus radical 2. So it means these 2 points are right here. Those are the 2 radicals are the solutions of this equation. So in other words, if I plug either one of them in here, I'll get 0. Okay. In fact, we can prove it right now. If x equals radical 2, let's see what happens. So that one worked. Beautiful. Let's try negative radical 2. Oh, by the way, these handwritten notes, I'm going to be posting them on Brightspace. So in other words, if you miss something or if it goes by too fast, I mean, you can certainly watch the recording again, but I will be posting these. There's no point in letting all this work go to waste. I mean, really. Now, I'm also going to try something new this semester. I'm trying to experiment with this thing called latex. And so if it works well, it may be possible to turn this into something that looks more like a typed up document. We'll figure that out later on. That's not that important. The important thing is that you'll have access to all these notes, but I might be able to make them look even more beautiful if I can figure out how to convert them into latex. So, all right, anyway, for this one, now, of course, when I square a negative number, it becomes positive. So once again, so that proves that both of these solutions are correct. Okay. All right, there we go. So what's next? So let's see, what do they want us to do here? They want us to, it says of graphing. Now, I see this all the time in these slides, graphing utility. I'm not quite sure what they mean by that. I interpret that to mean that you're allowed to use a program like Symbolab to visualize what they look like, because it's going to be very messy. Like here, for example, this is what's called a cubic equation. And so let's take them up on their offer to do this with Symbolab. Now, a cubic equation, potentially at least, will have 3 points where it crosses the horizontal axis. It doesn't have to, but it potentially could. X cubed minus 3x squared plus 2x plus 5. See, yeah, a cubic function has this unique curvature. It increases up to a point, then it starts to fall again, and then suddenly it starts to rise, and then it continues to rise forever. If you notice, it happened up here, so it only crossed the x-axis once, but it still has this unique curvature to it that you see with cubic equations. Classic example, this would be simply y equals x cubed. And yeah, it just cuts through the axis once. But in some cases, these cubic equations can actually cut through it 3 times, no more than 3, but up to 3 times. So yeah, like some of these other ones, by the way, in these cases, the signs will also have an influence on the shape of this curve. So like, for example, this one here, negative x cubed. In fact, I'll just simplify this. Let me just show you what negative x cubed looks like. Yeah, you see, it's like a reverse, it's like a mirror image from left to right. Um, so if you put them together, let's say in the same axes, they're symmetrical from left to right because of that negative sign. Okay. All right. Well, anyway, what else do we have? Intercepts. Now, of course, a function can have, it doesn't have to, but it can have 2 intercepts, one through the horizontal axis, one through the vertical axis. So that one we had before, We can try that here. So we already know the vertical intercept is 7. How about this one? Well, clearly x has some value, y is 0. What is the value of x here? Well, the way to find that is setting this equal to 0. And you're all set. So this is your horizontal axis, and sorry, horizontal intercept. And this is your vertical intercept, or sometimes it's called the y-intercept or the x-intercept. So the straight line, the equation only shows you the vertical intercept. If you want to know the horizontal, you have to figure it out yourself. But it's very straightforward. So here's some wacky graphs. Now this one on the left clearly is a quadratic equation. And yes, it doesn't have to cross the horizontal axis, but it will eventually cross the vertical axis. Here's a cubic equation. Like I said, you notice how it crosses 3 times. Now this is an interesting case. The one you're seeing here, and again, this is something that you would have seen in pre-calculus. This, whatever this is, this equation is, this is not a function. How can you tell? There's a very simple graphical technique that helps us identify functions. Let's compare these two side by side. What's the problem here? We have this so-called vertical line test. If a vertical line only crosses a graph once, then the graph represents function. Okay, so in other words, with y equals x cubed, no matter where we put this, right here, for example, x equals 3. Or over here, x equals -3. So the one on the left passes the vertical line test. This one does not, as you can plainly see. It crosses this vertical line, let's say it's x equals 5, crosses the curve twice, and therefore this one fails the vertical line test. And that implies that it's not a function. So you might say to yourself, well, what is it then? Well, if you remember from pre-calc, it is still a relation. It's not a function. Any set of ordered pairs forms a relation. It doesn't matter what their properties are, but in order to be a function, the point of a function is that each each x is uniquely associated with a y, or what I should say is each x, by which I mean element of the domain, is uniquely associated with a single value of y, meaning an element of the range. Okay, so here, for example, don't have that because x is associated with both. Let's say here y is -5 and here it's +5. So that means it can't be a function. So with a function, let me fix this a little bit. Each x, or element of the domain, is uniquely associated with a single value of y, meaning a single element in the range. That's clearly true here because, for example, when x is 3, y is 8. When x is -3, y is -8. Okay. But when the same x is associated with two different y's, that means it's not a function. And just as a quick reminder, the domain is the set of x values for which function is defined. Range of a function is the set of all possible values, or of all possible values of y are associated with the elements in the domain. So, this is something that there'll be a lot of discussion about ranges and domains. Like just as a quick example, here the domain is all the real numbers, as which you write like this. And so basically the thing about it this way, oh God, I have to fix that. It's a little messy. Let me just fix that a little bit. In other words, think about it this way. There is no value of x, which would lead to either division by 0 or an imaginary solution. So that means that's why domain is all the reals. But on the other hand, the range is restricted to the what we call the non-negative values. So we have a little bit of reviewing to do here because I just want to remind you that when it comes to intervals, the notation looks like this. Let's say you're looking at the real number line. This means everything between 1 and 2, but not including either one of these. Okay. By adding a square bracket like that, it means the 2 does count, but not the 1. Okay. The hollow circle means it's not part of the interval, but the solid black one means that it is. Okay. So you might remember this notation from a previous math class. This one means that 1 is included, but not 2. And then the fourth possibility is that both, actually, I think I better be a little neater here. Oh, that's better. Okay. And then if you have two square brackets, that means both endpoints are included in this interval. And of course, everything in between, that's understood. Okay, so those are the four possibilities. And there's formal names to these in math. This is considered to be an open interval. This is a closed interval. And then these two, there are different names for these. They're sometimes called semi-open, quasi-open, half open, things like that. Let's just run to the I wonder if there's a website that's just math terms. There probably is. What do you call an interval that only includes one end? So the square brackets mean you're including open. Oh, okay. They're telling us here that it should be at half open. Oh, see, there's another one. Wikipedia is telling us to call it half bounded. So you see, there's a lot of, that's one of the things about math. There's often many different names that mean the same thing. As you can imagine why, because math has evolved over hundreds and hundreds of years from many different parts of the world that spoke different languages. And of course, it's like, why does English have so many words that mean the same thing? It's the same thing. Because so many different countries came in and their languages were absorbed into English. But anyway, you get the point. Half open or half closed, sometimes they're called, means only one endpoint is included. Open means both, neither is included. Closed means both are included. That's an important idea. A lot of the definitions we'll see in calculus depend on the interval being either open or closed. It matters a great deal. Let's just put it that way. So this is awfully important. So anyway, why did I bring all this up? Because here, this range includes 0. On the other hand, whenever there's infinity or negative infinity involved, you never put a square bracket there, okay? By convention, that always gets an open or round bracket. So it means this one does include, and English-wise, notice how I use the terminology non-negative. Okay, so positive, of course, means x is greater than 0. But if x might be 0, we call that non-negative. Now there is a symbol in here somewhere, proper symbol for that. There it is. Then we have strictly negative, which of course means that x cannot be 0. It's negative. And then, of course, in the last case where it could be negative or 0, possibly 0, it's called non-positive. I think I have that symbol right here too. Yes, I do. All right. So just be aware of this notation, or I should not notation, sorry, terminology. Okay. Mathematicians in math, you have to be very precise with your language. There's no gray area in math. Everything is either correct or it's not correct. So you have to be very precise with your language. That's one of the cool things about it, isn't it? The fact that everything is either yes or no. It's right or it isn't. All right. Now they're throwing a challenge at us here. They want us to find the intercepts for this cubic function. They want us to split it up. Maybe we'll do this real fast just to get some practice. We're trying to figure out, obviously, the 3 points where it crosses the horizontal axis, the so-called solutions. God, I've got so much stuff open here. What was that again? X cubed minus 4x. All right, well, it's a cubic equation. It's going to have 3 solutions. Now, they don't necessarily cross the horizontal axis, but what I'm saying is that I can break this up into 3 what are called factors. So we'll start by factoring out the x. Now, the great thing here is that this is a quadratic expression. I can do one of two things. I can factor, or I can use the quadratic formula. So by factoring, I mean, this one is so simple, right? You can just see for yourselves that it's x plus 2 times x minus 2. But let's say you said, I don't understand how this works anymore. I've forgotten how to factor. Let's try the quadratic formula. This is a lot like the one we did earlier, isn't it? It sure is. Now, if you notice, this is 0. Now, if you subtract 4 times negative 4, you actually end up with 16. Plus or minus 2. So in other words, what this is saying is that x squared minus 4 equals 0. implies that x equals 2 and x equals 4, sorry, negative 2. But that means that the factors are x minus 2 and x plus 2. Okay, so that's why we can say up here, we have this result. And then that means that our original equation, x cubed minus 4x, can be written as x minus 2, x plus 2. Now, to solve for where it crosses the horizontal axis, we just set this equal to 0. And that implies that each of these individually equals 0. Okay. Because if any one of them equals 0, the product equals 0. So that means x equals 0, x equals 2, x equals negative 2. Okay. So the solutions of this quadratic equation are, and then when you draw this function, if you can visualize it as looking something like this. There you go. There's your sketch. All right. Interesting. Symmetry. Now, symmetry is a very important concept in that it basically means if something is a mirror image from either left to right or from top to bottom. That would be what, in a nutshell, what symmetry means. So, like a parabola is symmetric from left to right. There's actually a third possibility, by the way. Let me just grab this again. Meaning that what's going on over here is the same thing as what's happening over here. Um, this would be symmetric from top to bottom. But there's another way that a function could be symmetrical. The y equals x cubed is a perfect example of this. If just a quick reminder, the way this xy coordinate system works is we have 4 quadrants. So if a function is symmetrical between or with respect to, I guess we should say, the first and third quadrants, or second and fourth quadrants, it is said to be symmetrical with respect to the origin, meaning the point 0, 0. So, oops, the origin here. Okay, the origin. So, in other words, y equals x cubed is symmetrical about the origin from 1 to 3. But similarly, y equals negative x cubed that's a terrible graph. Hold on. that'll have to do. Um, Same thing. Um, it's also symmetrical, or it would be if I drew it properly, with respect or about the origin. So there's a way you can prove it without a graph. We want to be able to prove it. I mean, the graph helps us visualize what it means, but we always need a more formal way to prove it for every possible case. So that's what's coming next. They're going to show us the rules that will make it possible to determine if a function is symmetrical, or what type of symmetry it has, or no symmetry at all. Okay. Now, sadly enough, it's hard to believe, but it's already an hour. So my plan is to have these sessions be 1 hour at a time. I think that's about as much math as you can take at one time. Or anything for that matter. An hour is about right for any subject matter. After a while, it gets hard to concentrate. It's a lot of intense thinking. So my plan is to have these sessions last an hour or so each time. So when you're ready, you can start the next one, or if you need to recover for a while, you can do that too. Um, so we'll cut it off here, and then we'll carry on with the preliminary reviewing. And then after a couple more of these sessions, I think we'll be ready to start the new material. So um, I hope you have fun with this class, and I'll see you next time.